Hello class, it's Mr. Wicklehouse, and today we're going to talk about compound inequalities. All a compound inequality is two inequalities mashed together, typically separated by the word or the word and. Okay? So, let's take a look. So, compound inequalities. If they're not already a compound inequality, they could be made into two separate inequalities. So, if it's written like this, we can change it around to where it's going to be written something like this or this or something along those lines. Okay, just like any of the other, or just like the rules that we had with all inequalities before, we have to, if the x is not by itself, we have to get the x by itself. Okay. So, but as I said a second ago, compound inequality is it's two or more inequalities put together, and it's typically separated by the word or the word and. Okay? And this is typically how they'll look when you're messing around with them. Okay. So let's talk about what the word and what the word or means. And means that for the statement to be true, both equations have to be true. Okay, in other words, if x is less than 2 and x is greater than 0, the only solution is between 0 and 2. So, pick a number, let's say -3. So, is -3 a solution? Well, -3, when we plug those numbers in, -3 is less than 2, so that part is true, that checks out. But then when we go and plug it into the second equation, or second inequality, -3 is greater than 0. Is that true? No, -3 is less than 0. So that's not true. So -3 is not a solution to this compound inequality. Okay? Now, the word or tells us that only one equation has to be true, or one inequality has to be true. In other words, if x is greater than 2 or x is less than 0, the solutions are any number that is greater than 2 or any number that's less than 0. So it could be either or. So is -3 a solution? Well, yes, it is. -3 we know is less than 0. Okay, so that checks out. -3 is greater than 2, but that doesn't check out, but we don't care because this part of it was true. So yes, this is a solution to the inequality. Okay. Now we're going to combine all our knowledge together, and we're going to do some graphing and some solutions to these equations. Okay, so here's 4 examples. I'm going to work through all 4 of these examples today, and then tomorrow we'll have a little practice exercise at the beginning of class. Okay, so when you see them like this, what you want to do is you want to think about them as 2 separate inequalities. Okay, but we want to work them as 2 separate, but then we're going to combine them together at the end. So I'm going to think about this as one inequality over here, 4 is less than 2x. And then a separate one over here, 2x is less than 6. Now, using our previous knowledge that we had when we were working with inequalities earlier, we're going to divide this by both sides by 2 and get 2 is less than x. Over here, we're going to divide both sides by 2 again and say that x is less than 3. Okay. So when we put those, now we're going to put these two back together, and we're going to say that 2 is less than x is less than 3. Okay? So here's the solution to the compound inequality. But let's use some more previous knowledge and write these solution sets out. We'll do set builder notation and interval notation. Okay? So set builder notation, we're going to do our little squiggly bracket, x such that, and all we're going to do is we're going to plug this back in. 2 is less than x is less than 3. Squiggly bracket close. Okay, so that's set builder. Now interval, let's write our solution. Well, we're going to think about it like these. Well, the 2 is less than x, and it's not less than or equal to, so we do the parentheses. Okay, and then we're going all the way from 2 to 3, so 3 is the top part of that, and we close our parentheses. Okay. Alright, so these are our two solutions written like that, but what if I wanted to graph them? Well, let's do our little number line here. Here's 2, here's 3. Remember, 2 is not included, so I do an open circle. 3 is not included, so I do an open circle. And it's everything between 2 and 3, so it's all of this stuff in between. And there is our graph for those. Okay? Alright, let's look at this one. This one is already separated out into two inequalities, and it's separated with the word or. Okay, well, let's solve these inequalities first. I'm going to subtract 1 from both sides on this one, and I'm going to add 4 to both sides on this one. So I get x is greater than, sorry, wrong, x is less than -4. This one is going to be x is less than or equal to 6. Okay. So we'll do our set builder notation and our interval notation. Set builder notation, squiggle x such that x is less than -4 or x is less than or equal to 6. Squiggly close. This one is a little bit more difficult to think about. So in order to help us with that, I want to think about my graph. Okay. I'm going to start down here with -4, come up here to 6. Okay. X is less than -4. So there's that. Here's our graph for that. Or x is less than or equal to 6. X is less than or equal to 6. So we fill in the dot because it's less than or equal to, and it's all of this. So these two end up overlapping, and because this less than or equal to 6 ends up picking up that 4, and because this is or, I really don't care so much about that one because it's already included in this. Okay. Not only that, but that negative 4 gets picked up in this as well. So for our interval notation, when we thought about our graph, we're starting at 6 and going all the way down to negative infinity. Remember, the 6 is included, so we do the square bracket. Okay? All right. Here's one that is an and is a compound inequality. We're going to solve this. We're going to subtract 1. So we get 3x is greater than or equal to 3. Divide by 3. Get x is greater than or equal to 1. Do this one. Add 3. Negative 2x is greater than 8. Divide by negative 2. Remember, when we divide by a negative, we got to flip our sign. So x is less than negative 4. Okay. Well, this is x is greater than 1 and x is less than negative 4. Okay, let's try graphing that, because this will make it easier to think about what our next part is. Okay, so x, here's 1, here's negative 4. Okay. X is greater than negative 1, fill in the dot, we're going this direction. X is less than negative 4, open dot, we're going this direction. Now my question here is what is the solution here? Remember that this is the and, so we have both of these have to be true. Okay. Well, let's pick a number up here. Let's say 2. Okay. If I plug 2 into this, obviously 2 is greater than 1. But is 2 less than negative 4? No, 2 is not less than negative 4. Negative 4 is less than 2. So that doesn't work. Well, let's pick a number down here, negative 5. Negative 5 is less than negative 4. That part is true. But is negative 5 greater than or equal to 1? No, it's not. But think about this. Sometimes you'll have compound inequality. It'll say something like this. But when you go and you solve it out and you go to graph it and think about it for a minute, you'll find out that this is no solution. There are no numbers in the history of numbers that could be greater than 1 and less than negative 4 at the same time. So that one does not work out. Okay, so no solution. But the steps are still going to be the same. Okay. Let's look at this last one. I'm going to do this together as one inequality, but I'm going to think about it as 2. Okay. So I'm going to add 4. Wait a minute, I can't do it that way. Hold on. Mr. Wicklehouse had a brain fart. Okay, here we go. Alright, let us think about this as 2 separate ones. 2x minus 4, negative 2x minus 4, less than or equal to 7. Okay. we're going to add 2x here. We're going to get 7x is less than or equal to negative 4. We're going to divide by 7. X is less than or equal to negative 4 over 7. Here's this one. Add 4. Negative 2x less than or equal to 11. Divide by negative 2. Remember, we flip our sign. X is greater than or equal to negative 11 over 2. Okay. All right. Negative 4 over 7. Negative 11 over 2 is down here. This won't go how to do that one very well. So x is greater than negative 11 over 2. We're equal to, so there's our filled in dot going up this way. X is less than negative 4 over 7. Filled in dot. Everything here in between. Alright, so now we've got a graph, we've got our solutions. Sorry about the confusion there. Now let's write our set builder notation. This is going to be negative 11 over 2. Greater than or equal to x. So less than negative 4 over 7. This one is bracket negative 11 over 2 to negative 4 over 7. Alright, there we go. That's the end. And we are done, and I'll talk to you guys later.